Hi my dear students, welcome back to the class. So far we were discussing about trigonometric identities, isn't it? We discussed about various kinds of trigonometric identities that can be used in various situations, and we've done several problems in the example session. In this session we are going to solve exercise 3.3. There you can see a lot of problems which we can be solved by applying various trigonometric identities. We shall check it out. First question is, prove that sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus 1 by 2. We can just evaluate this LHS just by substituting these required values. We know the values. Sine pi by 6, it is nothing but what? 1 by 2. Again we know that cos pi by 3 is again 1 by 2. And also we know that tan pi by 4 is again 1. So we know these three values and we can easily substitute it to the left hand side of this proof. So LHS becomes sine square pi by 6, which is 1 by 2 square, plus cos square pi by 3, again it is 1 by 2 square, minus tan square pi by 4, it is nothing but 1 square. So it will become 1 by 4 plus 1 by 4 minus 1. It is nothing but 2 by 4 minus 1. It is equal to 1 by 2 minus 1 equal to minus 1 by 2 equal to the RHS. Hence, the result is proved. Now we shall do the second question. Here also we know the several basic value. We know that sine pi by 6 is equal to 1 by 2. Now we want cosec 7 pi by 6. We can convert this angle into cosec pi plus pi by 6, isn't it? Correct. Cosec pi plus pi by 6. Now we know that this is the first quadrant, second quadrant, third quadrant and fourth quadrant. Pi plus pi by 6 will definitely lie here. Here only tan and cot are positive. So the answer will be negative. And the sum is taken with the angle pi or a multiple of pi. Therefore, trigonometric ratio is not going to change. So it will become minus cosec pi by 6. Isn't it? Or else you can apply the formula for cosec x plus y. It's very simple also. So we get minus cosec pi by 6. And again we know that cosec pi by 6 equal to the reciprocal of sine pi by 6, and sine pi by 6 is nothing but 1 by 2, so it will become minus 2, isn't it? Now we know that values of cos pi by 3 also. What is the value of cos pi by 3? Again it is equal to 1 by 2. Now we can easily substitute in the left hand side. These values becomes LHS becomes 2 into sine square pi by 6 become 1 by 2 the whole square, plus cosec square 7 pi by 6 become 2 minus 2 square into cos square pi by 3 become 1 by 2 the whole square, isn't it? Now we shall just simplify it. 2 into 1 by 4 plus minus 2 square equal to 4 into 1 by 4. So it become 2 by 4 plus 4 by 4, isn't it? It is equal to 6 by 4 or it is equal to 3 by 2, which is the RHS of this proof. Hence, the result is proved. Similarly, we can do any kind of such problems just by substituting the values to the left hand side. Now we shall do the third question. The question is that prove that cot square pi by 6 plus cosec 5 pi by 6 plus 3 tan square pi by 6 equal to 6. This is what we have to prove. So, we know the basic values. Cot pi by 6. Since tan pi by 6 is equal to 1 by root 3, cot pi by 6 will be root 3. Now, cosec 5 pi by 6. It can be easily evaluated by splitting the angle cosec pi minus pi by 6, isn't it? Now, we know that since pi minus pi by 6 will lie in the second quadrant, and in the second quadrant we have sine and cosec are positive, so the answer will be positive, and the difference is taken from an integral multiple of pi, so the trigonometric function will never change, so it will become cos pi by 6. Now cosec pi by 6, since sine pi by 6 is equal to 1 by 2, cosec pi by 6 will be 2, isn't it? Now next one required is tan pi by 6, and as I have said, tan pi by 6 is nothing but 1 by root 3. Now we shall substitute all these values to LHS left hand side, so that the expression in the left hand side will become cot square pi by 6, which is root 3 square, plus cosec 5 pi by 6, it is nothing but 2, plus 3 into tan square pi by 6, which is 1 by root 3 the whole square. So it will become root 3 square is nothing but 3 plus 2 plus 3 into 1 by root 3 square, 3 into 1 by 3. So it will become 3 plus 2 plus 1 equal to 6 equal to the RHS. So LHS equal to RHS, hence the result is proved. Now we shall move to the fourth one. Here we have to find sine 3 pi by 4, isn't it? So sine 3 pi by 4 is nothing but, we can split it as sine pi minus pi by 4. As you know, it also will lies in the second quadrant, hence the result will be positive, and difference is taken from an integral multiple of pi, so it will become sine pi by 4. So sine pi by 4 is nothing but 1 by root 2. Now we want cos pi by 4, isn't it? Again we know cos pi by 4 is nothing but 1 by root 2, and we need sec pi by 3. Since cos pi by 3 is equal to 1 by 2, sec pi by 3 will be 2. Now we shall substitute all these quantities to the left hand side. The left hand side become 2 into sine square 3 pi by 4 equal to 1 by root 2 square, plus 2 into cos square pi by 4 equal to 1 by root 2 square, plus 2 into sec square pi by 3. So we have sec square pi by 3, sec pi by 3 equal to 2, so sec square pi by 3 will be 2 square. So it will become 2 into 1 by 2 plus 2 into 1 by 2 plus 2 into 4, isn't it? It is equal to 1 plus 1 plus 8 equal to 10 equal to RHS. So again LHS is equal to RHS, hence the result is also proved. Now coming on to the fifth question, we shall solve one by one. The first one is sine 75 degree. As you know, we can split sine 75 degree as sine 45 degree plus 30 degree, isn't it? It is of the form sine x plus y, and we know the formula for sine x plus y as sine x cos y plus cos x sine y. So it will become sine 45 cos 30 degree plus cos 45 sine 30 degree, isn't it? Sine x cos y plus cos x sine y, and we can have sine 45 degree is nothing but 1 by root 2, cos 30 degree is nothing but root 3 by 2, plus cos 45 degree is again 1 by root 2, sine 30 degree is equal to 1 by 2. So it will become root 3 plus 1 whole divided by 2 root 2. So this is the value of sine 75 degree. Now we shall find tan 15 degree. It can be rewritten as tan 45 degree minus 30 degree, isn't it? It is equal to tan 45 degree minus tan 30 degree whole divided by 1 plus tan 45 degree into tan 30 degree. Why this happens? Because it is of the form tan x minus y, and we know the formula for tan x minus y as tan x minus tan y divided by 1 plus tan x tan y. Now we shall just substitute the numerical value of each of the functions. It will become tan 45 is 1, tan 30 is equal to 1 by root 3 whole divided by 1 plus 1 into 1 by root 3, isn't it? It is equal to root 3 minus 1 divided by root 3 whole divided by root 3 plus 1 divided by root 3. So we can cancel root 3 common from both the sides. So it will become root 3 minus 1 divided by root 3 plus 1. Now we can just rationalize this fraction into a better form by multiplying numerator and denominator with root 3 minus 1. Why we are doing this is because to rationalize this fraction to a better form, also note that this multiplication doesn't make any change, since this number by this number gives us 1 and doesn't make any change to the fraction, and it becomes root 3 minus 1 into root 3 minus 1 equal to root 3 minus 1 the whole square divided by root 3 plus 1 into root 3 minus 1. It is of the form a plus b into a minus b, isn't it? We know that a plus b into a minus b equal to a square minus b square. So it will become root 3 square minus 1 square. So it is equal to we can have a minus b the whole square here. It will be root 3 square 3 minus 2ab 2 into root 3 into 1 plus 1 square b square. So by root 3 square is 3 minus 1 square equal to 1. It will become 3 plus 1 is nothing but 4 minus 2 root 3 divided by 2. We can cancel 2 from the numerator and denominator. So it will become 2 minus root 3. So this will be the value of tan 15 degree. Now we shall do the sixth question of your NCERT textbook. The question is that prove that this left hand side is equal to the right hand side. Okay. Now before moving into the question, we know that 2 cos A cos B is equal to cos A plus B plus cos A minus B, isn't it? Also we know that minus 2 sin A sin B is equal to cos A plus B minus cos A minus B. We know these quantities, isn't it? Let it be there. Now see that this is of the form cos A cos B. This is of the form sin A sin B. What is short is a 2 and a minus 2, isn't it? So in the first case, let me multiply and divide by 2 to become cos pi by 4 minus x into cos pi by 4 minus y. So I just multiplied and divided by 2 minus, okay, let it be plus. Now again here also I multiplied and divided by 2. So this plus into minus is actually minus. So for an easy method I took plus here and minus 2 taken inside. So it will become minus 2 sin pi by 4 minus x into sin pi by 4 minus y. So I just modified the left hand side in order to apply that identity. Now we know that 2 cos A cos B is equal to cos A plus B plus cos A minus B. So it will become 1 by 2 will be there, and this will become cos, in the stand of A we have pi by 4 minus x, and in the stand of B we will have pi by 4 minus y. So cos pi by 4 minus x plus pi by 4 minus y, isn't it? Let it be there. Not need to close this now. So cos A plus B is there now, plus cos A minus B plus cos pi by 4 minus x minus pi by 4 minus y. So this is the next quantity which should be enclosed in this bracket. So what I have done is I considered this as 2 cos A cos B. So it will become cos x plus y, A plus B plus cos A minus B. Again plus 1 by 2 into, this is of the form minus 2 sin A sin B, isn't it? So it is also equal to cos pi by 4 minus x plus pi by 4 minus y. Let it be enclosed in this bracket minus cos, again A minus B, pi by 4 minus x minus pi by 4 minus y. So this is the full bracket. What I have done is just modified this according to the condition. Now let me take 1 by 2 as common, so that 1 by 2 can be taken as common. Then see, plus cos pi by 4 minus x minus pi by 4 minus y, and minus cos pi by 4 minus x minus pi by 4 minus y will cancel, because these two quantities are the same with opposite sign. So when we add, this will result in 0, and the rest will become 1 by 2 into, see, this quantity and this quantity are exactly same. So we have 2 cos pi by 4 minus x plus pi by 4 minus y, isn't it? So this will be the result. Now I can cancel 2 over here, and also note that pi by 4 plus pi by 4 equal to pi by 2, and I can take minus common, so it will become cos pi by 2 minus of x plus y. What I have done is I just took minus common from x and y. Okay, see, this is of the form cos pi by 2 minus x, and we know that pi by 2 is here. hence the angle will lie here. Here all are positive, hence in the result will be positive. Since the difference is taken from an integral multiple of pi by 2, the trigonometric function will change to its cofunction, which is sine of x plus y. So this is equal to RHS. Hence we proved the sixth question also. It is a little bit confusing. If you use this identity correctly into this equation, then it is very easy to derive into the RHS. Now we shall prove the seventh question. The question is that prove that tan pi by 4 plus x is by tan pi by 4 minus x is equal to this. As we know, we can directly apply the formula for tan x plus y and tan x minus y here, isn't it? We know that tan x plus y is nothing but tan x plus tan y divided by 1 minus tan x tan y, and we know that tan x minus y is nothing but tan x minus tan y divided by 1 plus tan x tan y, isn't it? We can directly apply these two formulas into here. So let us apply that. Tan pi by 4 plus x, the numerator becomes tan pi by 4 plus x. We shall first evaluate the numerator. It is equal to tan pi by 4 plus tan x divided by 1 minus tan pi by 4 into tan x, isn't it? So it will become tan pi by 4 equal to 1. So it will become 1 plus tan x divided by 1 minus tan x. So this is the case. Now let us find tan pi by 4 minus x. So it will become tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. So it is equal to 1 minus tan x divided by 1 plus tan x. So we shall take the ratio. So the LHS becomes, so LHS is equal to the ratio of tan pi by 4 plus x and tan pi by 4 minus x, which means that the ratio of 1 and 2, isn't it? So LHS equal to 1 by 2. It is equal to 1 plus tan x divided by 1 minus tan x whole divided by 1 minus tan x divided by 1 plus tan x. So we multiplying it with the denominator with the reciprocal, it will become 1 plus tan x divided by 1 minus tan x into 1 plus tan x whole divided by 1 minus tan x, isn't it? So multiplying it will become 1 plus tan x the whole square divided by 1 minus tan x the whole square. So it will become 1 plus tan x by 1 minus tan x the whole square. So this is the answer. So we proved it is equal to RHS, hence the proof is complete. Now let us move on to the eighth question. The eighth question is that we have to prove this LHS is equal to this RHS. Let us consider the LHS. In LHS we want to find cos pi plus x, isn't it? It is equal to, as we know, when we draw the quadrants, cos pi plus x will lie here, and since here only tan and cot are positive, the answer will be negative. And since the sum is taken with an integral multiple of pi, the trig function will remain the same. So cos pi plus x is equal to cos minus cos x, and we have sin pi minus x. So sin pi minus x will lie here. Since here sin and cosec are positive, the answer will be positive, and since the difference is taken from an integral multiple of pi, the trig function will remain the same. Now we want cos pi by 2 plus x. See, cos pi by 2 plus x will lie here, and we know that cos pi by 2 plus x, since here only sin and cosec are positive, the answer will be negative, and pi by 2, since the sum is taken with an integral multiple of pi by 2, the trig function will change to its cofunction, so it will become minus sin x, isn't it? Now again cos minus x, we know that cos of minus x is equal to cos x itself. Now we shall substituting all these quantities into the LHS. LHS becomes sin pi plus x is equal to, cos pi plus x is equal to minus cos x into cos of minus x is equal to cos x divided by sin pi minus x is equal to plus sin x into sin cos pi by 2 plus x is equal to minus sin x. So it will become minus cos square x divided by minus sin square x, and minus will be cancelled, and it will become cot square x. It is equal to the RHS. Hence the result is proved. Now moving on to the ninth question. The question is that we have to prove this big expression is just equal to 1. It is very easy. We know that first of all we must remind this quadrant trick. So cos 3 pi by 2 plus x, this is 3 pi by 2. So this angle will be here, and here cos and sec are positive. Hence it will be, the answer will be positive. Let us write the LHS directly. LHS equal to cos 3 pi by 2x. So it will be positive, and since the sum is taken with an integral multiple of pi by 2, the trig function will change to its co-function, so it will be plus sin x. So LHS become plus sin x into. Now cos 2 pi plus x, as you know that 2 pi is here, so 2 pi plus x will lie here. Here all trig functions are positive, hence the answer is positive. Also we know that the sum is taken with an integral multiple of pi, hence trig function will remain the same. So it is cos x. So sin x into cos x into, let us enter into the bigger bracket, cos 3 pi by 2 minus x. This is 3 pi by 2. So 3 pi by 2 minus x will lie here, and here cot and tan are positive, hence it will be positive. Since the difference is taken from an integral multiple of pi by 2, it will change to tan x. So that will be tan x plus. Now again cot 2 pi plus x. Here 2 pi and 2 pi plus x will lie here. So the answer will be positive, since in this quadrant all are positive. Also cot 2 pi, the sum is taken with the integral multiple of pi. So it will become cot x itself. So tan x plus cot x. So this is the bigger expression reduces to a smaller expression. Now we know that sin x into cos x. Let it be here. Again tan x is nothing but sin x by cos x plus cot x is nothing but cos x by sin x, isn't it? Let us take the LCM in this bracket. It will be sin x into cos x into sin x is equal to sin square x plus cos x into cos x is equal to cos square x divided by sin x into cos x, isn't it? Since these two are same, we can divide this to 1, so it will go. So the remaining is sin square x plus cos square x. It is nothing but 1. It is equal to RHS. Hence the result is proved. So this is the end of question number 9 in your NCERT textbook. Now we shall go to question number 10. Now we shall move on to the question number 10. The question is that we are given with a lengthy LHS and a small RHS. We have to prove that these two are equal. So easily you can observe that in the LHS we have sin A sin B format, and there is a term cos A cos B format. We know that minus 2 sin A sin B is nothing but cos A plus B plus minus cos A minus B, isn't it? Also we know that 2 cos A cos B is equal to cos A plus B plus cos A minus B. So if we convert these terms into this form, then we can easily apply these formulas, isn't it? Let us check. First I am going to multiply the numerator and denominator of this term by minus 2. So it will become minus 1 by 2 into minus 2 sin n plus 1 into x sin n plus 2 into x. So this becomes the first term, plus again I am going to multiply the numerator and denominator of this term by 2. So it will become 1 by 2 into 2 cos n plus 1 into x into cos n plus 2 into x. So we get a second term like this. Now we know that we can easily apply these formulas in these bracketed terms, isn't it? So it will become minus 1 by 2 into, it is nothing but here a n plus 1 into x stands in the space of a, n plus 2 into x stands in the space of b. So cos a plus b. So it is cos n plus 1 into x plus n plus 2 into x. Cos a plus b plus, minus cos a minus b. So it will become cos a plus b minus cos n plus 1 into x minus n plus 2 into x. So this is the second term of the first content. So this is the very first bracket plus 1 by 2 into, again we have the same and we can apply this formula. It will become cos n plus 1 into x plus n plus 2 into x, isn't it? Plus cos a minus b. So it will become cos n plus 1 into x minus n plus 2 into x. So it will be in the second bracket. Now you can see that we can open this entire thing into the same bracket, or we can take 1 by 2 common and we can multiply this thing with the minus. So it will become 1 by 2 into, when I multiply the entire thing with negative sign, it will become, this will be positive and this will be negative. So cos n plus 1 into x minus n plus 2 into x minus, so it will be negative, cos n plus 1 into x plus n plus 2 into x, and the bracket, sorry, no need to close the bracket since we have taken 1 by 2 as a common number. So it will become plus cos n plus 1 into x plus n plus 2 into x, again closing bracket, plus cos n plus 1 into x minus n plus 2 into x. So the entire bracket now can be closed, isn't it? And you can see that here we have minus cos n plus 1 into x plus n plus 2 into x, and here we have plus cos n plus 1 into x plus n plus 2 into x. So the terms will be negative of each other and will be cancelled. So we have 1 by 2 into, and you can see that this term and this term is identical. So it will become 2 cos n plus 1 into x minus n plus 2 into x, isn't it? We taken these two terms added together to get 2 times. And again you can see that it is equal to 2 and 1 by 2 cancels. We can simplify the angle in itself. Cos n plus 1 into x, it becomes nx plus x minus nx minus 2x. So it will become cos minus x, isn't it? And we know that cos minus x is nothing but cos x, and it is equal to the RHS. Hence we get LHS equal to RHS. Hence the theorem is proved. Now coming on to the 11th question, we have to prove cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x is equal to minus root 2 sin x. So let us begin with the left hand side as usual. But if you can observe that left hand side is of the form cos a minus cos b, isn't it? We know that cos a minus cos b is nothing but minus 2 sin a plus b by 2 into sin a minus b by 2, isn't it? So this is the formula or identity for cos a minus cos b. So from it we have cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x is nothing but minus 2 sin, in this place of a we have 3 pi by 4. So 3 pi by 4, so 3 pi by 4 plus x, 3 pi by 4 plus x a plus b. So it is again 3 pi by 4 minus x. So in the case, because in the place of b we have this angle, whole divided by 2. So it will become a plus b by 2 into sin a minus b by 2, which means 3 pi by 4 plus x minus 3 pi by 4 minus x whole divided by 2. So this becomes the formula of left hand side. So the left hand side becomes this on applying this identity. Again we can again simplify it as it is equal to minus 2 sin. You can see that this is nothing but 2 3 pi by 4, isn't it? That is 2 into 3 pi by 4 whole divided by 2. See, this is 2 into 3 pi by 4 because this 2 cancels. So this is the first content, and the next one is sine. Again you can see that 3 pi by 4 and 3 pi by 4 cancels, and what remains is x plus x, it is 2x whole divided by 2. Again we can simplify it further as 2 and 2 cancels, 2 and 2 cancels. It becomes minus 2 sine 3 pi by 4 into sine x, isn't it? Now we know sine 3 pi by 4 is equal to sine pi minus pi by 4, isn't it? it lies on the second quadrant, hence it is positive. So it is nothing but sine pi by 4 and it is equal to 1 by root 2. So on substituting this value here, it will become minus 2 into 1 by root 2 sine x, isn't it? Since minus 2 can again be written as minus root 2 into root 2 sine x whole divided by root 2, and root 2 by root 2 cancels, so it will become minus root 2 sine x. Hence it is equal to the RHS. Hence the result is proved. Coming on to the 12th question, the question is that prove that sine square 6x minus sine square 4x is equal to sine 2x into sine 10x. It's very easy because as you can see that it is of the form a square minus b square. We know that a square minus b square is nothing but a minus b into a plus b, isn't it? By using that identity, we can split the LHS as sine 6x plus sine 4x into sine 6x minus sine 4x. Okay, let it be there. Now we know that sine a plus sine b is equal to 2 sine a plus b by 2 into cos a minus b by 2, right? Also we know that sine a minus sine b is equal to 2 cos a plus b by 2 into sine a minus b by 2. Okay, so we shall apply these identities here. Hence we have this sine 6x plus sine 4x can be expanded using the first one. It is equal to 2 sine a plus b by 2. 6x plus 4x is equal to 10x. 10x by 2 is equal to 5x into cos a minus b by 2. 6x minus 4x is equal to 2x. 2x by 2 is equal to x into again sine 6x minus sine 4x. We can use this identity. 2 cos a plus b by 2, again 6x plus 4x 10x, 10x by 2 5x into sine a minus b by 2 sine 6 minus 4 2x by 2 equal to x. So we get this. Now we shall just rearrange this. So it will become 2 sine 5x. I am taking this to this position and this number trigonometric function to this position. So it will become 2 sine 5x cos 5x into 2 sine x cos x. I am able to do this because multiplication is commutative and associative, so that I can easily transform one number in a multiplication to any position. Like I know 2 into 4 into 6 is nothing. This is same as 2 into 6 into 4, and it is same as 6 into 2 into 4. The order doesn't matter. That's why I am able to rearrange this. Again, you know that 2 sin x cos x is sin 2x, isn't it? Suppose that this is considered as y. 5x is considered as y. Let y is equal to 5x. Then it is of the form 2 sin y cos y, which is sin 2y, isn't it? Let it be there into 2 sin x cos x. It is sin 2x. Okay. Now again you know that y is equal to what? 5x. So substituting this will get sin 2 into 5x, which means sin 10x into sin 2x, which is the RHS, required RHS. Hence the result is proved. Question number 13 is also very much similar to the previous problem. Here also we can split the left hand side as cos 2x plus cos 6x into cos 2x minus cos 6x. Very simple, and I think you can do the rest by the similar method of the previous problem. We should apply the identities which suits these two terms, and we can just simplify it to get this right hand side. So this is a free check for your previous knowledge. You can try it out, and we shall move on to the next one. Now we shall do the 14th question. In 14th question we have to prove this left hand side is equal to this right hand side. So let me first begin with the left hand side and just rearrange the left hand side into more convenient form. That is, I am rearranging it as sin 2x plus sin 6x plus 2 sin 4x. I just done rearrange these two terms just like this. Now this is of the form sin a plus sin b, isn't it? We know that sin a plus sin b is equal to 2 sin a plus b by 2 into cos A minus B by 2. Correct. So let me just substitute that formula here. So it will become 2 sine 2x plus 6x divided by 2 into cos 2x minus 6x divided by 2 plus 2 sine 4x. Correct. Now let me just simplify this. It will become 2 sine 2x plus 6x is 8x and 8x by 2 is nothing but 4x into cos 2x minus 6x is again minus 4x by 2 is equal to minus 2x plus 2 sine 4x. Correct. Now it is equal to 2 sine 4x into cos minus 2x is equal to nothing but cos 2x. We know that. So it is plus 2 sine 4x. Again I can take 2 sine 4x as common, isn't it? So it will become 2 sine 4x into cos 2x plus 1. Again we know that cos 2x is nothing but 2 cos square x minus 1. Let me just substitute that here. It will become 2 sine 4x into 2 cos square x minus 1. So now opening the bracket, it will result in 2 cos square x minus 1. Again there is a plus 1, isn't it? So it will become 0. So it will become 4 sine 4x into cos square x, which was the required RHS. So hence we proved LHS is equal to RHS. Now we shall do the question number 15. We have to prove this LHS is equal to this RHS. We are doing this in a special manner, that is we are taking LHS and simplifying it, and we are taking RHS and simplifying it, and finally we are showing that both the simplified terms are same, so this will be equal. So let us begin with this. So the LHS is equal to cot 4x is nothing but cos 4x divided by sin 4x, isn't it? Into sin 5x plus sin 3x. Now we know that this is of the form sin A plus sin B. So we can apply the formula. So it is equal to cos 4x divided by sin 4x into, this formula is nothing but sin A plus sin B is nothing but 2 sin A plus B by 2 cos A plus A minus B by 2, isn't it? So it will become 2 sin 5x plus 3x divided by 2 into cos 5x minus 3x divided by 2. So this is the left hand side. So we shall just simplify it. It will become cos 4x divided by sin 4x into 2 8x sin 8x by 2 is nothing but sin 4x into cos 5x minus 3x is 2x, 2x by 2 is 1, so cos x. Again you can see that we can cancel sin 4x from both the sides, so it will become 2 cos x into cos 4x. So let it be the equation number 1. Now let me take the RHS and simplify. We know that cot x is nothing but cos x divided by sin x into, again we know that this is of the form sin A minus sin B, isn't it? Sin A minus B is nothing but 2 cos A plus B by 2 divided into sin A minus B by 2. We know that. So on substituting this formula directly here, it will become 2 cos 5x plus 3x divided by 2 into sin 5x minus 3x divided by 2. So it will become cos x divided by sin x into 2 cos 5x plus 3x is 8x, 8x by 2 is equal to 4x into, again this is sin 5x minus 3x is sin 2x by 2 sin x. So we get this and we can cancel these two together, and it is equal to cos x cos 4x, isn't it? Which is equation number 2. And you can see that equation number 1 and equation number 2 are same. So we can say that LHS is equal to RHS. Hence the result is proved. Now we shall do the question number 16. We have to prove the left hand side equal to the right hand side, and you can easily observe that the left hand side is of the form cos A1 minus cos B1 divided by sin A1 minus sin B1, isn't it? We know that cos A1 minus cos B1 is nothing but minus 2 sin A1 plus B1 by 2 into sin A1 minus B1 by 2, isn't it? Divided by, Again we know that sin a1 minus sin b1 is nothing but 2 cos a1 plus b1 by 2 into sin a2, sorry, not a1 and a2, here angles are different, so a2 and b2 must be taken. So cos a2 plus b2 by 2 into sin a2 minus b2 by 2. So we shall just substitute these things into here. It will become minus 2 sin a1 plus b1 by 2, sin 9x plus 5x, it is 14x, 14x by 2 is nothing but 7x, into sin a1 minus b1 by 2. So 9x minus 5x is nothing but 4x. So 4x by 2 is nothing but 2x, whole divided by 2 cos a2 plus b2 by 2. 17x plus 3x is 20x. 20x by 2 is nothing but 10x, into sin a2 minus b2 by 2. 17x minus 3x is 14x. 14x by 2 is 7x. So as you can see, we can directly cancel these two and these two, and hence the answer will be minus sin 2x divided by cos 10x, which is the RHS of this given equation, and hence LHS is equal to RHS, hence the result is proved. So we have to prove that LHS is equal to the RHS in the 17th question. Here we have given with an LHS which is of the form sin A plus sin B and cos A plus cos B, isn't it? We have LHS is of the form sin A plus sin B divided by cos A plus cos B. We know the formula for sin A plus sin B is equal to 2 sin A plus B by 2 into cos A minus B by 2, whole divided by cos A plus cos B 2 cos A plus B by 2 into cos A minus B by 2. We know this. We can directly substitute the values into this equation. So the equation will be 2 sin A plus B by 2. So 5x plus 3x 8x. So A plus B by 2 will be 4x. 2 sin 4x into cos A minus B by 2. 5x minus 3x is 2x. 2x by 2 is x, divided by 2 cos A plus B by 2. 5x plus 3x 8x. So by 2 4x into cos A minus B by 2. 5x minus 3x is 2x. So it will be cos x. Cancelling the like terms, it will become sin A 4x divided by cos 4x, and we know that is equal to tan 4x, which is the RHS of this equation. So LHS is equal to RHS, hence the result is proved. Now coming on to the 18th question. The 18th question, left hand side is directly of the form sin x minus sin y divided by cos x plus cos y. We know that sin x minus sin y is nothing but 2 cos x plus y by 2 into sin x minus y by 2, correct, divided by cos x plus cos y is of the form 2 cos x plus y by 2 into cos x minus y by 2. Exactly. Now we can cancel the like terms, which means on division this will result in 1, and we have sin by cos, which is tan x minus y by 2, which is the RHS of this entire equation. So we have LHS equal to RHS, hence the result is proved. Coming on to the 19th question, which is also very similar to the previous problem, we shall directly consider the LHS. It is of the form sin x plus sin 3x divided by cos x plus cos 3x, and it is equal to, we know that sin x plus sin y, it is of the form sin x plus sin y, so it will be equal to 2 sin A plus B by 2, so x plus 3x by 2 into cos x minus 3x by 2, whole divided by cos x plus cos y, it is nothing but 2 cos x plus y by 2, that is x plus 3x by 2 here, into cos x minus 3x by 2. And you can see that the like terms are this and this and 2 and 2. So it will divides and it is equal to 1. So we have tan x plus 3x by 2. Since sin by cos is tan, it is equal to tan x plus 3x is 4x by 2 is 2x. So tan 2x, which is the RHS of this equation. Therefore we have LHS equal to RHS, and hence the result is proved. Coming on to the 20th question, we have to prove this left hand side equal to the right hand side. Like we shall consider the left hand side. It is equal to sin x minus sin 3x divided by sin square x minus cos square x, isn't it? We know the numerator is of the form sin a minus sin b. So we can directly apply the formula 2 cos a plus b by 2. 3x plus x is 4x. 4x by 2x is equal to 2x. So 2 cos 2x into sin a minus b by 2, that is x minus 3x by 2. X minus 3x is minus 2x. Minus 2x by 2 minus x whole divided by. And you can see that this formula is very familiar. We know that cos square x minus sin square x equal to cos 2x, isn't it? But here we have sin square x minus cos square x. Therefore, this will be equal to minus cos 2x. We should multiply both sides with minus so that we get the left side equal to this one. So again you can see that we can cancel up these two things. So it will be minus 2 sine of minus x. But we know that sine of minus x is nothing but minus sine x, isn't it? Then minus and minus multiplied together to give plus 2 sine x, which is the RHS of this equation. Therefore LHS equal to RHS, hence the result is proved. Coming on to exercise number 21, we shall going to prove this left hand side equal to just cot 3x. First of all, let us rearrange this numerator and denominator a little bit. So left hand side equal to cos 4x plus cos 2x. I just relocated cos 2x to the second position plus cos 3x whole divided by sin 4x plus sin 2x plus sin 3x. Here also I just relocated sin 2x and sin 3x. Again, this is of the form cos A plus cos B. And this is of the form sin A plus sin B, isn't it? So we shall just apply the formulas for sin, cos A plus cos B and sin A plus sin B in the respective positions. So cos A plus cos B equal to 2 cos A plus B by 2. 4x plus 2x is 6x. 6x by 2 is equal to 3x. And cos A minus B by 2. 4x minus 2x is equal to 2x. 2x by 2 equal to x. So 2 cos 3x cos x plus there is a cos 3x there. We can see that. Whole divided by. It is of the form sin A plus sin B. It is we will get 2 sin A plus B by 2. 4x plus 2x is 6x. 6x by 2x is equal to 3x into cos A minus B by 2. So when we will get cos 4x minus 2x, it is 2x. 2x by 2 equal to x. So cos x plus there is a sin 3x. So sin 3x. Now from the first portion we can just take cos 3x as common. So it will become cos 3x into 2 cos x plus 1. Again from the denominator we can take sin 3x as common. So sin 3x into 2 cos x plus 1. As you can see that this 2 divides to 1 and what remains is cos 3x by sin 3x. It is equal to cot 3x. Hence the result is proved. Now we shall do question number 23. Prove that tan 4x is equal to 4 tan x into 1 minus tan square x divided by 1 minus 6 tan square x plus tan raised to 4x. This is what we have to prove. Before we begin, always remember that tan 2x is given by the formula 2 tan x divided by 1 minus tan square x, isn't it? So we shall just apply this formula over and over here to get the right side. So let us begin with LHS. It is equal to tan 4x. It is again equal to tan 2 into 2x. So it is of the form tan 2x, isn't it? Instead of x we have 2x only. So it will become 2 tan. Instead of x we have to put 2x divided by 1 minus tan square 2x. Again I am going to apply the formula of tan 2x in this equation. So it is equal to 2 tan 2x is again 2 tan x divided by 1 minus tan square x whole divided by. So this is the numerator part, whole divided by 1 minus tan square 2x, which means tan square 2x means actually tan 2x the whole square. Okay, so we have to find tan 2x the whole square. So it is again 2 tan x divided by 1 minus tan x tan square x the whole square. Applying the formula over and over again in this simple equation. So it will become, let us cross multiply, let us simplify this. So 2 into 2, 4, it is equal to 4 tan x divided by 1 minus tan square x. 1 minus tan square x whole divided by, we can cross multiply this. Actually this is 4 tan square x, this is 1 minus tan square x the whole square, that is 1 minus tan square x the whole square must be cross multiplied here. So 1 into 1 minus tan square x the whole square minus square of this, that is 4 tan square x whole divided by, the common denominator is 1 minus tan square x the whole square. Now let us multiply the denominator fraction into the this fraction by multiplying with the reciprocal. So it will be 4 tan x divided by 1 minus tan square x into, the numerator will be what? 1 minus tan square x the whole square whole divided by this denominator 1 minus tan square x whole square minus 4 tan square x. Okay, so we have this much equations and we can just cancel this one and this square easily, isn't it? Now the numerator become 4 tan x into 1 minus tan square x, and the denominator, it is of the form a minus b the whole square. So a square plus b square, which is tan raised to 4x minus 2ab, 2 tan square x minus, here we have 4 tan square x. So on simplifying these thing we get 4 into tan x into 1 minus tan square x whole divided by 1 minus 2 minus 4 is equal to minus 6 tan square x plus tan raised to 4x, which is the RHS of this given equation, and hence LHS equal to RHS, hence proved question number 23. Now coming on to question number 24. Prove that cos 4x is equal to 1 minus 8 sin square x cos square x. We shall begin as quickly as we can because we know the formula for cos 2a. So we can split cos 4x is equal to cos 2 into 2x. We know that cos 2x is nothing but 1 minus 2 sin square x, isn't it? So in the place of x we have 2x. So it becomes 1 minus 2 sin square 2x. Correct. That is 1 minus 2 sin 2x the whole square. Again we know the formula for sin 2x. It is nothing but 2 sin x cos x. So on substituting we get 1 minus 2 sin x, 2 into 2 sin x cos x whole square. It is equal to 1 minus 2 into 2 square equal to what? 4 sin square x into cos square x. Again 2 into 4 is equal to 1 minus 8 sin square x cos square x. Hence it is equal to the RHS. Therefore LHS is equal to RHS, hence the result is proved. Hence I believe all these questions we have done in this exercise is very well clear for you, and the last one, question number 25, can be done by you if you saw all of these questions very well, and I am giving you that as a homework. Just try it out, and if you don't get the answer, drop a comment here. We shall do it in the next video.